Okay, students, now the lesson Ionic equilibrium, session 5, common ion effect. When salt of the weak acid is added to the acid itself, the dissociation of weak acid is suppressed further. So, this is the idea for this is the concept for this common ion effect. When a salt of the weak acid is added to the acid itself, the dissociation of weak acid is suppressed further. Okay, for example, the addition of sodium acetate to acetic acid. Sodium acetate is the salt of acetic acid. The solution leads to suppression in the dissociation of acetic acid, which is already weakly dissociated. Okay, because weak acid only the partial dissociation is there. In partial dissociation also the salt of acetate is added, it is suppressed the dissociation of acetic acid. So this is the concept for common ion effect. In case acetic acid and sodium acetate, CH3COH and CH3CONA have the common ion, acid is common ion CH3CO minus, also acetate is also have a CH3COO minus ion. So analyze why this happens. Now we will see the what happened in this salt solution. Salt is added to this acid. Acetic acid is a weak acid. It is not completely dissociated in aqueous solution. We already saw the last sessions. Completely it's not completely dissociated. Weak acid only partial dissociation is there. Hence the following equilibrium exists. What is the equilibrium? Acetic acid, that is CH3COOH, equilibrium H plus and CH3COO minus. Okay, in water. However, added salt, the sodium acetate salt completely dissociate to produce sodium plus and CH3O minus ion. After that, in acid we mix with sodium acetate completely dissociate. Okay, see this equation. CH3COONA gives Na plus and CH3CO minus. In both equation, CH3CO minus ion is a common ion. Hence overall concentration of CH3CO is increased. Now both reactions CH3CO minus ion is there, therefore concentration is increased. The acid dissociation equilibrium is disturbed. So the concentration of CH3COO minus is increased, the equilibrium is disturbed. We know that Le Chatelier principle, when a stress is applied to the system at equilibrium, underline it. When a stress is applied to the system at equilibrium, the system adjusts itself to nullify the effect produced by that stress. What are the stress produced by the effect is nullify, because the system at equilibrium adjusts itself. The whole system is adjusts itself to nullify the effect. Okay. So in order to maintain the equilibrium, in the maintain equilibrium, the excess of CH3CO ion combines with H plus ion again to produce the acetic acid molecule. So the equilibrium will shift towards the left. Left side means reactant. In other words, the dissociation of acetic acid is suppressed. This is the reason. These 4 points are the reason for the suppression. Suppression takes place in this common ion effect. Okay. The dissociation of weak acid is suppressed in presence of salt. This is the condition. Weak acid have the weak acid is mixed with sodium acetate, that is salt, presence of his their salt containing the common to the weak electrolyte, common ion electrolyte, it is called the common ion effect. Okay, this is the most important 3-mark question or 5-mark question. Okay. Next concept, the buffer solution. What is the buffer solution? General equation. In general, our blood maintains a constant pH irrespective of number of cellular acid-base reaction. In our body, the blood have so many salt, so many bases, and then maintain the circulation of blood is maintains all the pH values. pH maintain constantly the pH values. Why? Because the due to the buffer action. In our blood, the pH value is maintained throughout the life, because it is possible due to buffer action. So what is a buffer? Buffer is a solution which consists a mixture of weak acid and conjugate base, or weak base and conjugate acid. This is the buffer. Conjugate base with weak acid, or weak base with conjugate acid. This is the buffer action. Very, very important 2-mark question. What is a buffer? Okay. This buffer solution resists the drastic changes in its pH upon the small quantities of acid bases, and this ability is called buffer action. What is buffer? We see that conjugate base with weak acid, or weak base with conjugate acid. So in this, any salt, small quantity of acid or bases added to this, it maintain the standard. This is called the buffer action. The buffer solution resists drastic changes in the pH upon addition of small quantities of acid and bases, and this ability is called buffer action. Buffer containing, example, buffer containing carbonic acid and conjugate base HCO3 minus, carbonium ion. Carbonic acid HCO3 minus ion is present in our blood. In blood, carbonic acid is there, and then also conjugate base HCO3 is also in there. The 2 types of buffer solution, one acidic buffer solution, another one is basic buffer solution. Acidic buffer solution means weak acid and its salt. Acidic buffer solution, weak acid and its salt. Example, acetic acid and sodium acetate. Basic buffer solution, the solution contains weak base and acid. It's salt. Weak base and its salt. Ammonium hydroxide and ammonium chloride. Example. Okay. Next, buffer action. What is buffer action? to resist changes in its pH on the addition of an acid or a base, the buffer solution contains both acidic as well as basic components. Once again, to resist the changes in its pH on the addition of acid or base. If any solution we add the small weak acid or weak base, we add the small amount of acid or bases, addition of acid or bases, the buffer solution should maintain both acidic as well as basic components to neutralize the effect added acid or bases at the same time. These components should not consume each other. This is the condition. Buffer action means in acid or bases mixed with their salt, they maintained throughout the constantly. We add acid or bases one small amount. The buffer solution neutralize the effect of acid base at the same time. This should not consume each other. These components should not consume each other. No action takes place with its acid or bases. Okay, this is the example. Let us explain the buffer action in a solution containing acetic acid and acetate. The dissociation of buffer components occurs as below. Okay, now CH3COH gives CH equilibrium. CH3COH equilibrium, CH3COO minus and H3O plus ion. CH3CONA H2O with water, H2O, CH3CONA plus Na plus. In both this equation, the CH3COO minus of the concentration of CH3COO minus is increased. Okay. Next, if an acid is added to this mixture, it will be consumed by the conjugate base. The conjugate base CH3COO minus ion. It is a conjugate base to form undissociated weak acid. It forms undissociated weak acid, that is increase the concentration of H plus, does not reduce pH significantly. Okay. If acid is added, before that the two equations CH3COH equilibrium CH3COO minus plus H plus, again CH3CONA plus gives CH3COO minus plus Na. In both the mixture of this, we add small amount of acid is added, they consumed with CH3COO minus to form undissociated weak acid. So the increase the concentration of H plus does not reduce pH significantly. The H plus ion does not reduce pH value. Okay. Next, base is added. In base, this is the acid. The CH3COO minus H plus consume, and then again acetic acid is formed. If the base is added, it will be neutralized by H3O plus, and the acetic acid is situated to maintain the equilibrium. The pH is not altered. So two equations are there, two steps are there. OH minus plus H3O plus gives H2O. H2O the OH minus ion is from base. Base is added to H3O plus ion, it gives the water. And then CH3COH also gives equilibrium, CH3COO minus plus H3O plus. Both we add the equation, cancel H3O plus, this side H3. Next whole OH minus aqueous plus CH3COH gives CH3CO minus and H2O. This is the balancing final equation for these neutralization reactions are identical to those reactions have already discussed in common ion effect. Earlierly we already saw the definition, the neutralization with acid and bases. Steps are, these neutralization reactions are identical to those reactions. Now we see the problems in buffer action. Some problem number 1, problem number 2. Okay. In problem I write the values of this acid and salt, the buffer solution. In buffer solution, 0.8 mole acetic acid, 0.8 mole CH3CONA. Now see the problem. What is the problem? Problem is, let us analyze the effect of addition of 0.01 mole of sodium hydroxide, solid sodium hydroxide, to 1 liter of buffer solution containing 0.8 mole of acetic acid and 0.8 mole sodium acetate. Assume that the volume change due to addition of sodium hydroxide is negligible. Now we see the dissociation constant of acetic acid. Okay. Now in detail, in buffer solution, 0.8 mole acetic acid, 0.8 mole sodium acetate. We add 0.01 mole of sodium hydroxide in this solution. Volume change due to addition of any of which is negligible. Now Ka value for acetic acid is equal to 1.8 into 10 to the power of minus b. This is already given in this question. Let us see the equation. CH3COO H equilibrium, CH3COO minus plus H plus. Its concentration of equilibrium, for acetic acid 0.8 minus alpha, CH3CO minus ion have alpha, H plus have alpha. CH3COONA gives in water mixed with water, CH3CO minus plus Na plus. Its concentration at equilibrium 0.8, already gave the questions. Buffer solution 0.8 mole of acetic acid, 0.8 mole of sodium acetate. So 0.8 gives 0.8 of CH3CO minus ion and 0.8 mole of Na plus ion. Now we go to the Ka value. Dissociation constant of acetic acid is Ka is equal to product divided by reactant, that is CH3CO minus into H plus concentration divided by CH3COH concentration. Now this is moved to the left side of Ka with Ka. CH3CO minus and H plus is equal to Ka into CH3COH concentration. Now H plus is leave and then CH3 move to the bottom of the that is in denominator. CH3 COH divided by CH3CO minus. Okay. Next, H plus ion is directly proportional to Ka. Remove the Ka. Therefore, directly proportional to acetic acid divided by ion CH3CO minus ion. Now, dissociation, degree of dissociation is of acetic acid is CH3COH is equal to 0.8 minus alpha. 0.8 minus alpha. In equation already note the equation. That is CH3CO minus ion alpha plus 0.8. Here this alpha and then 0.8. The alpha plus 0.8. Now H plus is equal to Ka into 0.8 minus alpha divided by 0.8 plus alpha. In case of weak acid means alpha less than 0.8. So it is negligible. Negligible means 0.8 minus alpha is equal to 0.8. 0.8 plus alpha is already also 0.8. Okay. Now next step, H plus is equal to Ka into 0.8 divided by 0.8, cancel it, and then H plus concentration is equal to Ka. Therefore, Ka for acetic acid is equal to 1.8 into 10 to the power of minus 5. So H plus is equal to 1.8 into 10 to the power of minus 5. So pH is equal to minus log H plus formula is equal to minus log H plus, fill the H plus value 1.8 into 10 to the power of minus 5 minus log, you split it, minus common log 1.8 in before the step multiplication is there. So here plus, we write the plus symbol and then 10 to the power of minus 5. So move to the multiply inside the bracket, minus log 1.5 plus 5 means this minus 5 is moved to the before log, power is moved to the before log. So 5 minus 5 and log based. Okay. Already have outside minus into minus plus. Okay. Minus 5 and minus also plus. So I write the plus 5. Understand? Now 5 plus 5 into 1 minus log 1.8 is equal to 0.26. Fill the value. pH is equal to 4.74. This is the final value for before adding the salt solution. After addition of the salt, that is base, 0.01 mole of NaOH to 1 liter of buffer solution. After addition, the volume change due to addition of NaOH is negligible. So OH minus concentration is equal to 0.01 mole. We already in question. So equation CH3COOH equilibrium CH3 COO minus and H plus. CH3COOH concentration, dissociation value 0.8 minus alpha, then alpha. CH3CO Na 0.8. This is before already see the equations, these steps. Now add the base. Question 0.101 mole of NaOH added. CH3COH plus OH gives CH3CO minus plus water molecule. H plus OH add to combine with to produce water molecule. So CH3COH concentration is equal to 0.8 minus alpha from this 0.8 minus alpha minus 0.01. 0.01 is where the base already added, so it is the value 0.79 alpha. Okay, CH3CO minus is equal to alpha plus 0.8 plus 0.01 here and then 0.01 already mole of NaOH is added, so alpha plus 0.8 plus 0.01. If in this alpha is less than 0.8, so 0.79 minus alpha is equal to 0.79, 0.81 plus alpha is equal to 0.81, because alpha is negligible. So H plus is equal to Ka into acetic acid divided by concentration of acetic divided by concentration of ion, CH3CO minus ion. So Ka value, substitute the Ka value 1.8 into 10 to the power minus 5 into 0.79 divided by 0.81 is equal to 1.8 into 0.79 divided by 0.81 into minus 5. So H plus is equal to 1.76 into 10 to the power of minus 5. pH is equal to, next we see the pH value, pH is equal to minus log H plus concentration is 1.76 into 10 to the power of minus 5. You split the log minus write common before bracket and then log 1.76 plus 10 to the power of minus 5. So multiply with multiply by inside the bracket minus inside the bracket minus log 1.76 minus already in the power, this power is there, minus 5 before you write before the log minus 5 log 10. So minus into minus plus 5 and minus log 1.76, 5 minus the 1.76 value is 0.25, 5 minus 0.25 is equal to 4.75. This is the pH value is after addition of the sodium hydroxide, 0.01 mole of sodium hydroxide value. Okay, before that 4.74, after that 4.75. So the pH value is the maintaining throughout the solution after addition of base, any base or any acid. So this is the conclusion. Okay.